Okay, it's day 2 of particle motion. And we start out by saying that speed is the absolute value of velocity. It's how fast it's moving without regard to. So add a without regard to the direction, whatever. So in this case, all the velocities are positive, so the speed graph and the velocity graph look alike. In this graph, you have negative velocity, but the speed is positive, so it's just going to reflect across the x-axis. I don't think we ever asked you that. Okay? All right. Here they gave us, make sure you check it, the velocity graph. They want between 0 and a. Velocity is negative because it's below the x-axis. The acceleration is negative because of the slope. Since they're the same, it means that the speed is increasing. From C to D, I have positive velocity. It's above the x-axis. My slope is negative, so it's decreasing. Okay? From A to B, here we are. You have negative velocity. It's below the x-axis and positive slope, so it's decreasing. And from B to C, you have positive velocity and positive slope, so it's increasing. That's a review. Did that, okay? All right. This is kind of interesting. This one, it tells you it's a particle movement. It's position, not velocity, okay? So when is it moving to the left? You have to look at the slope. You have a negative slope from 0 to 1 and from 4 to 6. Negative slope, okay? When does it reverse directions? When it changes from negative slope to positive slope, so that would be x equals 1. When does P move at its greatest speed? You're looking at the steepness of the line. You have the steepest line from 4 to 6. Okay, is there a guaranteed time that the velocity is 3/8? Well, the slope here is negative 1/2, and the slope here is positive 1/2. Is that right? It went up 1.5 over 2. So 3/2 over 2 is 3/4. Okay, so that's 3/4. No, because the velocity is constant. It's the slope of the line, so no. Okay, I think they meant for that to be a velocity graph, and then the answer would be yes. What can we say? All right, the graph below represents velocity, okay? It has a semicircle and 2 line segments. At what time is the speed the greatest? So you're looking for the distance away from x-axis. So the furthest away at x equals 8. Okay? Times 2, 6, and 9, where is the acceleration the greatest? At 2, it's right here. Your acceleration is 0. Oh, let me redo that. A of 2 is equal to 0. A of 6, that's over here, is the slope of that line, which is what? 1, 2, 3, 4, 5, 6. 6 over 4. And at A of 9, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 over 3. So this one wins. Okay? Over what time interval is the particle moving left? It's negative. V of t is negative. So it's from 4 to 10. What time is the speed decreasing? So your velocity and your acceleration have to be opposite signs. So here I have positive velocity and negative acceleration. Here I have negative velocity and positive acceleration. So what's that? 2 to 4 and 6 to 10. Okay, this one's velocity again. When is it moving left? From 1 to 4 because it's negative. When is the speed decreasing? They have to be opposite. So you got positive with negative slope and negative with positive slope. So 1 to 1, no, 0 to 1, and 3 to 4. Is there a guaranteed time when the particle's at rest? Yes, when velocity is 0, so at x equals 1, or t equals 1. Okay? This time we gave us a table. Is the particle moving left or right at t equals 0? You'd say left because it's negative. Is there a time when the particle's at rest? Yes, between 0 and 2 because it changes signs. Use the data to approximate V10. Okay, so V10 is in between here. So I'm going to do 5 minus 7 over 12 minus 8, which is 2 over 4, which is negative 2 over 4. It's negative a half. It's feet per second squared. It's acceleration. The derivative of velocity is acceleration. Use your units. This is feet per second over, or feet per minute over minute. Oh, it's meters per second. Meters per minute. Oh, read the directions. It's meters per minute squared. Okay, but use your units. All right. The average acceleration from 0 to 80, 49 minus 5 over 80 minus 0 is 4 over 80. 44 over 80, which is 11 over 20. What? Feet per second squared. Is there a time when it's at rest? No. Never changes sign. Approximate V45. So you have 40 minus 35 over 50 minus 40, which is 5 over 10, which is a half feet per second squared. It's acceleration. There you go. Done. That's all there is to these. And don't forget to watch the next video on linear approximation.